Hey everyone, so in this video I'm going to be showing you how to use a method called completing the square. Now completing the square is going to be a method that will be used to convert a quadratic relation from standard form into vertex form. So there's a couple things I want to remind you of. So firstly, I'm just going to remind you what vertex form looks like. So here's an example of a quadratic relation that's written in vertex form. So y is equal to 3 times x minus 2 squared plus 3. Okay, and standard form, well, an example of the same quadratic relation written in the standard form, we y is equal to 3x squared minus 12x plus 15. And I just want to remind you, if I wanted to convert this from vertex form into standard form, we would basically just expand and simplify. So again, what we're going to be doing is we're going to be talking about how to convert from standard form into vertex form. So that would be going the other way around. And in order to do this, the method is called completing the square, right? So complete the square is what we're going to be doing here. Okay, so before we go into actually how to complete the square, there's going to be a few steps that we're going to have to go through. The first thing is I'm going to have to remind you of a couple of little formulas that we've discussed. So I want you to remember that if we have something written in the form of a squared plus 2 times a times b plus b squared, well, we call this an example of a perfect square trinomial. And we talked about factoring this sort of thing. We said if we have a perfect square trinomial that looks like this, well, that's going to factor into a plus b to the power of 2. And then there's a second perfect square trinomial. The second one is a squared minus 2ab plus b squared. Okay, so if we have an expression written like this, a perfect square trinomial like this, that means that it can be factored to look like a minus b to the power of 2. So these are going to be important things to remember when we kind of go through the process and sort of develop the skills required to do this. Okay, so before we actually discuss how to complete the square, again, there's going to be a couple things we're going to have to deal with. I figured that a good idea would be to start by discussing or to maybe remind ourselves how we're going to expand and simplify to get from vertex form into standard form. So let's take a look at a particular example. We're going to consider y is equal to 2 times x plus 3 squared plus 1. So this is in vertex form. Now, if we want to convert this into standard form, we're going to expand and simplify. Now, the first step in expanding this sort of thing would be to take x plus 3 squared and write it as x plus 3 times x plus 3. And then we would expand out the x plus 3 times x plus 3. And that's going to give us something that looks like this. 2 times x squared plus 6x plus 9, and then plus 1. So again, I didn't show all the little steps in between, but if you'd like to, you can give it a try yourself, and you should end up with this. The next step would be to take the 2 out front and expand it into the quadratic trinomial in the brackets. Okay, so if we do that, that's going to give us 2x squared plus 12x plus 18 plus 1. And then I'm going to get you to notice that we have positive 18 and plus 1, and those are going to combine, and we're going to get 2x squared plus 12x plus 19. Okay, so why are we going through this? This is something we've discussed before. Well, I'm going to identify a couple things that are going to be important to us here. So the first thing I want you guys to look at is this expression right here. So this is a quadratic expression quadratic trinomial in brackets. Now, if you remember where this came from, right, well, this is what we got by doing x plus 3 squared from the first line. So we square x plus 3, we end up getting x squared plus 6x plus 9. So here's the thing. If we're going from standard form back into vertex form, which is the goal of completing the square, what we're going to want to do is we're going to want to take something that looks like this trinomial, x squared plus 6x plus 9, and we're going to want to write it as x plus 3 squared. Well, what we're doing when we're performing that move is we're noticing that x squared plus 6x plus 9 is actually a perfect square trinomial. In this case, it's one of the form a squared plus 2ab plus b squared. And in this case, our a would be represented by x, our b would be represented by 3, so we end up getting x plus 3 squared. So basically, we're just factoring the perfect square trinomial, right, to get it to look like the first line. So that's the first thing I want to remind you, or get you guys to notice. Okay, the second thing I want you to notice is going to be a relationship between these two numbers, the positive 6 in front of the x and then the plus 9. There's an interesting relationship between these two because of the fact that this expression is a perfect square trinomial. So let's take a look at this. What we're going to do is we're going to take the positive 6. I'm going to take half of positive 6. Now, one way to take half of positive 6 would be to divide it by 2. And then I'm going to take the number that we get, and we're going to square it. So in other words, I'm taking the positive 6, I'm dividing it by 2, and I'm squaring the result. Okay, well, positive 6 divided by 2, well, that's just positive 3, so we're going to be squaring positive 3. Well, if we square positive 3, what do we get? Okay, well, that gives us 9, positive 9. Well, hold on. Notice that that's the exact number we have there. Now, this is always going to be the case whenever you have a perfect square trinomial. If you take the coefficient of the middle term, so the coefficient of x, take half of it, square that number, you will end up getting the final number in the perfect square trinomial, in this case, the plus 9. So that's going to be important. Okay, so another thing I want to mention to you is, again, down here we have something that looks like it's in standard form. We know that we're supposed to be going towards vertex form. Okay, well, what we're going to want to do here is we're essentially going to be working backwards. We're starting from something in standard form, where we're trying to get to vertex form, and that means that partly what we're going to want to be able to do here is take something like our last line and make it look something like our second last line, and then what we're going to do is we're going to factor the perfect square trinomial to make it look like the top line. And that is basically what we're going to be doing when we're completing the square. Okay, so let's take a look at another example, because I think it's important to kind of go through what's going on here. So let's take a look at this example. So consider y is equal to 3 times x minus 1 squared plus 2. So we're going to do the same thing we just did on this quadratic in vertex form. So again, the first thing you would do if you were going to expand this into standard form is you'd take x minus 1 squared and you write it as x minus 1 times x minus 1, and then you would multiply those two binomials, and that would give you something that looks like 3 times x squared minus 2x plus 1, and then we have plus 2. Okay, and then of course what you do is you would expand in the 3 and so on. I'm not going to show all of the steps. We're just going to focus on what we have here. And actually it looks like I missed the squared, so I'll put it in. There we go. Okay, so again, I'm going to draw your attention to this particular trinomial right here. Okay? Now again, this is a perfect square trinomial, that means there's going to be a relationship between this number negative 2 in front of the x and then the number 1 at the end. So let's take a look. That means if I take this negative 2, we're going to do the same thing we did in the last one. We take the negative 2, we take half of it, so that means I'm going to divide it by 2, and then I'm going to square the result. Okay, well, negative 2 divided by 2, that's negative 1. So what we have here is negative 1 squared. If I square negative 1, that gets us 1. And I'm going to get you to notice that that's the number that we have right here. So again, because x squared minus 2x plus 1 is a perfect square trinomial, there's this relationship between the middle coefficient and the constant at the end. And that's going to be important for what we're going to be doing next. Okay, so what we're going to do here is we're going to do just a couple of little examples. So the example we're going to look at is what value should k be to make the expression a perfect square trinomial. So what I'm going to do here is I'm going to give you a quadratic expression. It's going to have some unknown k in it, and we're going to have to determine what value k needs to be in order to make the expression a perfect square trinomial. So let's take a look at our first particular example. So if we have x squared plus 10x plus k, all right, we need to find out what is k going to be so that this is a perfect square trinomial. Again, the reason why we want to make it a perfect square trinomial is because we're going to want to be able to factor it as a perfect square trinomial. Okay, well, how are we going to do this? Well, again, we're going to use the relationship between the middle coefficient and the constant at the end. So in this case, we're going to take the positive 10. We're going to take half of it, so let's divide it by 2. We're going to square that, and let's see what that's going to give us. Well, positive 10 divided by 2, well, that's 5, so we're going to be squaring positive 5. And if you square positive 5, well, that just gives you 25. And that actually means that this is the number that k should be, 25. Okay, well, that means that I could take the original expression that we have, and I could write it as x squared plus 10x plus 25. And this would be a perfect square trinomial. Now, I'm going to take this a step further. Because of the fact that this is a perfect square trinomial, if I wanted to, I could factor it as a perfect squared trinomial. And I'm going to give you a little bit of a quick way to do this, right? There's a fairly simple way to do this based upon the work we just did. Okay, so this is going to factor into x plus 5 squared. Okay, well, how did I get the plus 5? Well, the plus 5 is going to be the number that we got in that middle step when we were finding k. So after we took positive 10 and divided by 2, we got positive 5. Well, since we got positive 5, that's going to be what we put inside this set of brackets. So x plus 5 all squared. So that would be the factored version of the perfect square trinomial we have. And if you wanted to, you could double check. You could take x plus 5 squared, write it as x plus 5 times x plus 5, multiply it out, and you should get x squared plus 10x plus 25. Okay, let's take a look at another example like this. This time we're going to work with the expression x squared minus 8x plus k. So once again, we're going to find out what k needs to be in order to make this a perfect square trinomial. Okay, well, to do that, we're going to rely on the relationship between the middle coefficient and the constant at the end of a perfect square trinomial. So we take a look at the minus 8. We're going to divide it by 2 and then square it. Negative 8 divided by 2 is going to be equal to negative 4. So we have negative 4 squared. And I'm going to remind you that that negative 4 is going to be important if we want to factor the perfect square trinomial we're going to end up with. Before we do that, what is negative 4 squared? Well, it's 16. And that means that the k value we're looking for must be 16. Okay, so that's great. That means I could rewrite the original expression as x squared minus 8x plus 16. And now, just like we did before, we're going to take this a step further, and we're going to factor this as a perfect square trinomial. Well, remember, the second step in finding our k value, right, was basically where we had negative 4 to the power of 2. That negative 4, that number that we're squaring there, is going to be what we're going to use to factor this perfect square trinomial. And that means that this is going to factor into x minus 4 squared. And again, that's because we got the minus 4 in that second step. So x minus 4 squared. Okay, so this is actually the majority of the difficult part of doing the method called completing the square. We're going to be using this inside of completing the square, inside of that method. Right? There's a couple other things as well. But this is really the tough part for most people. So I figured it'd be good to kind of go through this as a separate example. But what we're going to do now is we're going to go through a particular example of the full method of completing the square. In fact, I'm going to go through 2 examples with you, but let's start with the first one. So remember, the goal of completing the square is to take a quadratic relation that's in standard form and rewrite it in vertex form. So the question says, convert to vertex form. Okay, let's take a look at our first example. We have y is equal to x squared minus 2x plus 7. So this is a quadratic relation that's in standard form. And I'm going to get you to notice that the leading coefficient, that'd be the coefficient in front of the x squared term, is 1 here. Now, the fact that it's just 1 is going to be kind of important to us, all right? I'm going to show you an example afterwards where we don't have 1. But let's just say you have an example that looks like this where the leading coefficient is 1. First step you're going to want to do is you're going to want to toss a set of brackets around the first 2 terms, like this. So just around the first 2 terms, you can leave the plus 7 outside. Okay? Now, the next thing that we're going to do is the stuff inside the brackets, we are going to want to force that stuff to be a perfect square trinomial. Okay, how are we going to do that? Well, what we're going to do is we're going to toss a value inside the brackets, a k value. And essentially, we're going to do the same thing that we did on the last page. We're going to ask, okay, well, what does k need to be in order to make this expression a perfect square trinomial? So we put just some extra value k inside the brackets. Okay, but that's only the stuff in the brackets. Outside the brackets, we're going to have our plus 7. And then you might think to yourself, hold on, you can't just go adding stuff into an expression like this. Like we added k in the brackets. You can't just go adding stuff randomly into an expression. That changes things. And you'd be right if that's what you were thinking. So what we're going to do is we are going to essentially cancel out that plus k that we just added in. Well, by putting plus k inside that set of brackets, we just added k to this expression. So if I wanted to rebalance, if I wanted to cancel out what I just did, I could just take this expression and just subtract out k. So since we added k inside the brackets, we're just going to subtract k back out at the end, and that means that our expression hasn't been changed. Okay, great. So now what we're going to do is we're going to figure out what k has to be in order to make the stuff in the brackets a perfect square trinomial. All right, well, what does k need to be? Well, again, we're going to rely on the relationship between the middle coefficient of a perfect square trinomial and that constant at the end. So what are we going to do? Well, we're going to take the negative 2, which is the coefficient of the x term. We're going to take half of it. That means we're going to divide it by 2. We're going to square that number. And let's see what we get. Well, negative 2 divided by 2 is negative 1. So we're going to get negative 1 squared. And that negative 1 is going to be important to us after. Right? But what is negative 1 squared? Well, it's equal to 1. And that means that k has to be the number 1. So what we're going to do is we're going to go back to our expression and we're going to replace k with the number 1 anywhere that we see it in our expression. So that's going to give us x squared minus 2x plus 1 plus 7 minus 1. Okay, great. So now, since the expression in the brackets is a perfect square trinomial, I should be able to factor it. Okay, and remember, we're going to be able to factor it using that second step of finding the k value. Okay, well, what's that going to look like then? Well, let's see. That second number inside, sorry, that second step of finding the k value gave us negative 1 squared. That negative 1 is going to be important. And that means that we're going to be able to factor the stuff inside the brackets into x minus 1 squared. Okay, so the x squared minus 2x plus 1 that's in the line above gets factored into x minus 1 squared. And then we have the plus 7 and minus 1 to deal with. Well, those we can just collect. Positive 7 minus 1, well, it's just positive 6. Now take a look at this. This is an example of a quadratic relation that's in vertex form now. So this is now in vertex form. We started with something that was in standard form, it's now in vertex form. And that's the full method of completing the square, at least for this example. Now since it's in vertex form, we could do some interesting things with this. For example, one thing we'd be capable of doing is stating what the vertex is. And in this case, the vertex would be at 1 and 6. Okay, so I think we should do another example, but in this example, I'm going to show you what to do when we have a leading coefficient in front of the x squared term. So let's take a look at another example here. Let's say we have y is equal to 3x squared plus 12x plus 2. Okay, so notice that in front of the x squared, we have the number 3. So 3 is the coefficient of the x squared term. It's our leading coefficient. Okay, so we're going to have to do a couple of extra things in this example since we have a leading coefficient. But the first step is going to be essentially the same. We're going to toss a set of brackets around the first two terms. Okay, so the second step is where things go a little or get a little bit different. Now, because we have a leading coefficient of 3, what we're going to do is we're going to common factor out the leading coefficient, the number 3, from these first two terms. Now, I just want you to take out the coefficient, just the number 3. I know that inside the brackets, there's also a common factor of x, but we only care about taking out the leading coefficient. So we're going to common factor out just the number 3 from these first two terms. Okay, when we do that, we take the 3 up front, and then inside the brackets, we're going to ask ourselves what would we need to multiply 3 by to get each term? Well, 3 times x squared gives us 3x squared, and 3 times positive 4x gives us positive 12x. So we have 3 times x squared plus 4x. Okay, now we have our plus 2. Okay, great. So again, we tossed a set of brackets around the first two terms, and then we just common factored out the leading coefficient only. Okay, so now inside that set of brackets, we're going to do the same thing that we did above. What we're going to do is we're going to put in a value k, and that's going to make the stuff inside the set of brackets a perfect square trinomial. Okay, so that's going to give us 3 times x squared plus 4x plus k. So again, for some value of k, inside the brackets, we're going to have a perfect square trinomial. Okay, now the stuff outside the brackets. Well, we're going to have a plus 2, okay? And then you might think to yourself, okay, we just added in a k inside the brackets, so we're going to subtract out a k. And that's close, but it's not quite right. This is the second place where having a leading coefficient is going to make things a little bit different. What we're going to do here is instead of subtracting k, we're going to subtract 3k. You might ask yourself, why were we subtracting 3k? Well, the reason why is because our leading coefficient was 3. By putting the k inside the brackets, essentially what we just added was 3 times k. So we added in 3k, so in order to rebalance, we have to subtract out 3k. Okay, great. So now what we're going to do is we're going to find out what value k needs to be. And we're going to do this as rough work to the side. So to get k, what we're going to do is we're going to take the coefficient of the middle term, so that's going to be positive 4. We're going to divide it by 2, and then we're going to square it. Okay, well, positive 4 divided by 2, that's just positive 2, so we're going to square positive 2. And remember, that positive 2 is going to be important to us after, but what is positive 2 squared? Well, it's positive 4. So now what we're going to do is we're going to substitute that 4 in anywhere we see a k. All right, so that's going to give us 3 times x squared plus 4x plus 4 plus 2 minus 3 times 4. Okay, so now a couple things we can do from here. The first thing we can do is inside of our brackets, we should now have a perfect square trinomial. And that means that we should be able to factor it as a perfect square trinomial. And remember, we're going to be using the number we got from that second step of finding k. So that means the bracketed stuff is going to factor into, so we have 3 times x plus 2 squared. Now again, the plus 2 comes from that term we ended up getting, that number we ended up getting from the second step of finding k. We got positive 2 squared, so that positive 2 goes inside of our brackets to give us x plus 2 squared. Okay, now we're just going to deal with the stuff outside the brackets. We've got positive 2 and then minus 3 times 4. I could do negative 3 times 4 quickly, so that's going to give us positive 2 minus 12. And then the last thing we're going to do is we're going to take that positive 2 and that minus 12, and we're going to combine those. Positive 2 minus 12 is negative 10, so it's going to give us 3 times x plus 2 squared minus 10. So this is now in vertex form. And again, that means that we could do stuff like maybe state the vertex. So in this case, the vertex of the quadratic relation would be at negative 2 and negative 10. So what I recommend doing is maybe going through, when you're going through some examples, if you're not used to this method, what you could do is maybe start this video back from one of these 2 examples I did on this page, pick the one that looks most like the question you're working with, and maybe follow the example again step by step until you kind of get used to what you're supposed to be doing. That's how I'd recommend using these 2 examples from this page anyways. Anyhow, I hope that helps with the method called completing the square. Take care.